In this video, we're going to learn about lattice energy. Lattice energy is defined as the energy released when 1 mole of an ionic compound is formed from its individual ions. So let's say we've got a sodium cation and a chloride anion. They're attracted to one another, and if I hold them separate from one another, there exists a potential for them to come together. That potential energy is the lattice energy. And if I move them closer together, that potential energy decreases until they stick together. So another way of looking at lattice energy is if I've got the ions that are stuck together and I pull them apart, in that case, I'm investing energy. So this is a positive value of energy, and I can pull them apart and eventually they are totally separate from each other. That is the exact opposite of lattice energy, which would be a negative value because it's defined as the energy released. So moving on, let's address what it is that affects how much lattice energy exists in a compound. And it's Coulomb's law. Coulomb's law, that we learned when we were discussing periodic trends, for example. In that case, we framed it as you have a positive nucleus and a negative electron, and we have to consider how strongly attracted they are. In this case, we have a positive cation and a negative anion, and we're going to address how strongly attracted they are to one another. The principles are the same. The greater the values of Q1 and Q2, which are the positive and negative charges, the stronger the lattice energy. So in the case of sodium fluoride, our ions are +1 and -1. Our Q values are +1 and -1. But in the case of magnesium oxide, they are +2 and -2. So based on that, we can say that magnesium oxide probably is going to have a greater value of force attracting and therefore a greater lattice energy than sodium fluoride. We can also look at the distance of separation, and that has to do with the size of the ions, which actually are pretty close, but we can say that because the magnesium and oxide ions are a little bit smaller than the sodium and fluoride ions, that makes the R² value a little bit smaller for magnesium oxide, so that too will lead us to the conclusion that magnesium oxide has a greater force of attraction between ions and therefore a greater lattice energy when put together. So I next want to address the effects that lattice energy can have. The next video will address how you can compare lattice energies using T-charts, so don't worry about that for now. But the effects of lattice energy, well, the more lattice energy there is in a compound, the higher its melting point and the harder it is, which you may recall from planet Earth means the more scratch resistant it is. So let's go to 2 minerals that you might recall from planet Earth, calcite and halite. Calcite is calcium carbonate, calcium having +2 ions and carbonate having -2 ions, halite being sodium chloride with +1 sodium and -1 chloride. This might suggest that calcite has a stronger force of attraction and greater lattice energy. So we can predict that calcite is probably going to have a higher melting point, which it does, and it also is going to have a greater hardness, which it also does. In fact, you can scratch halite with your fingernail, but calcite will resist scratching under your fingernail because it's harder. So that's all for this video. Hope it's helped. Feel free to leave any questions or comments in the comment section below, and thanks for watching.